Hello student, good morning. Today we will start the flight adaptation in birds. Most present day aerial birds are heavier than air, heavier than air machines, and almost every part of their organization has been modified for aerial life. To fly in air, they have to possess following essential specialization in their morphology, anatomy, and physiology: organs for flight, lightness and rigidity, evolution of extra energy with provision for high power, speed and balancing and control, body control. Because speed is most must for aerial life, so to minimize the resistance offered by air during flight, the body of most birds is fusiform or spindle shaped, and it lacks any extra projections which may offer resistance in the attainment of speed in air. Further, the attachment of wings high upon the thorax, the high position of light organ like lungs and sacs, and low position of heavy muscles, sternum and digestive organs, and consequently low center of gravity and other morphological facts of great significance. Body covering of feathers, body covering of feathers, whole body covered the feathers. Body of all birds is covered by special integumentary derivatives called feather. Feathers are diagnostic of birds since no other group of animals kingdom has ever developed them. Feathers have following advantages for birds: the smooth, closely fitting and backwardly directed counter feathers make the body streamlines and reduces the friction of the minimum. The feathers covering makes the body light and at the same time protects from the hazards of environmental temperature. The feathers hold a considerable blanket of enveloping air sound the body and add much to its buoyancy. The non-conduction covering of feathers insulates the body perfectly and prevents loss of heat, which enables the birds to endure in the intense cold at high altitudes and also to maintain a constant temperature. Feathers of wings form a board surface for shrinking the air. Organs for flight: the forelimbs have transformed into unique and powerful propelling organs. The wings are the sole organs of flight. These organs have complicated structures construction consisting of a framework of bones, muscles, nerves, blood vessels, feathers, etc. Both wings springs from the anterior region of trunk. During rest, they remain folded against sides of the body, but during flight they become expanded. The surface area of the wings is increased by the development of elongated flight feathers. The remains the vein of each remains forms a flexible and continuous surface for sticking the air in flight. The flight feathers of wings also form a broad surface for supporting the birds in air. The particular shape of the wings with thick strong leading edge converges. Upper surface and concave lower surface causes reduction in air pressure above and increase below with minimum turbulence behind. This helps in driving the birds forward and upward during flight. Mobile neck and beak. Mobile neck and beak. The transformation of forelimbs into wings is duly compensated by the extreme mobility of the long and flexible neck for reaching food. The month is drawn out into a horny beak which acts as a pair of forceps in picking up the things and in various other activities such as nest buildings, pruning, etc., which are normally done by forelimbs in other animals. Bipedal locomotion. As anterior part of the body of birds becomes concerned with flight, the posterior part of body becomes modified for movement on land, for locomotion on the ground, and to support the entire body weight. The hind limbs occupy somewhat anterior position on the trunk and become more stouter. Perching. The hind limbs of birds are well specialized for an arboreal life. Their muscles are developed in such manner that when a bird sights on a branch of the tree, the toes close round the twig automatically. This happens due to so-called perching mechanism. When the bird settles on the branch of a tree, the legs are bent and puts the flexor tendons on the stretch with the extension of the pulley. The toes are bent spontaneously around the perch. A bird can go to sleep in this position without any fear of falling off. Short tail. Tail is very short. The short tail of birds bears a tuft of long tail feathers or rectrices which spread out in a fan like manner and serve as a rudder during flight. They also assist in steering, lifting, and counterbalancing during flying and piercing. Flight muscles. The action of the wings are controlled by the flight muscles, which are greatly developed, while the muscles of the back remain greatly reduced. The muscles fibers comprising the flight muscles are long and striated to withstand fatigueness after prolonged activity. The important flight muscles are pectoralis major. The powerful downstroke of the wings is caused by the immense muscles. Pectoralis minor, the rising or elevation of the wings is caused by these muscles. Coracobrachialis muscles. These small muscles aid in depressing the wing. Tensors fatigilis muscles help to keep the fatigia tensils stretched when the wings are extended. The flight muscles are highly vascularized structures. The subclavian artery is very stout, divides into two branches, a pectoral artery to supply the flight muscles and an axillary artery to the wings. Lightness and rigidity of endoskeleton. Lightness and rigidity of endoskeleton. This lightness and rigidity of endoskeleton is continually taking place in the next lecture. Okay, thank you.